Good morning, everybody. Welcome back to lecture number 2. So before we start, I want to make an important announcement. From now on, I'm not going to upload the slides on the Blackboard because every time I upload something, I make changes, you will get emails. So if all the changes will be on the OneDrive. Can you please now try to access OneDrive using either your phone or your tablet? If you cannot access it, let me know. Also, keep in mind that always please refer to the latest slides. Always I make updates. Okay, how do I know that you made an update? One is you can see the history in the drive, or two, the naming convention. The naming convention, you will read revision 01, revision 02, revision 03, so always get the latest revision. Okay, I download the revision, I took notes in the class. Does it really matter? To some extent, yes, but you're not gonna miss a lot if you make the corrections using your own notes. So I encourage you to still take the notes, every lecture, download the files. Two is we will have, I personally prefer to have one big module. So by the end, before the major exams, you have one set of slides rather than based on lectures. You get 5, 6 slides for just one topic. So the first 2 digits are reserved for what? Module number. So what was the last lecture's module?
00.
Read it from the OneDrive. What is this lecture module?
The first one 00.
What's the second one?
01.
So 01, if you go to the syllabus, there is a bolded text on the top. It says review of basic electric circuits. So probably we'll spend 2 weeks on 01 slides. So it's gonna get bigger and bigger and bigger and bigger. So at the end you'll have one big file where you can study for it rather than having different lectures. Okay? I personally think this is more efficient and convenient. Okay? If you take notes on the slides, you can have multiple versions. I will try my best to make the revisions not much, but it is what it is. Always get the latest.
يعني طب تقدر تفصل بين كل موضوع أو سكشن حاجة تكون في فصلة؟
Then we will have situations where I go to, it's by title. So for example, title 1 is going to be history. But I'm not going to have many files. It's hard. It is hard. Because always I don't know where to stop. That's the cause of the problem. So let's say I stop here and I go there. Just take it all. And I don't think you have iPad. Do you have iPad? Are you taking notes in the class on your notebook or iPad? Yeah, this is maybe impacting more those who take notes in the iPad, but do your best, okay? You know my policy of attendance? If I already attended you, you want to leave it? Focus, okay?
I was like to ask.
Did you ask?
No.
You're not happy?
No. Sorry, just explain.
Okay, Shabab? Use your time efficiently, okay? Okay, Shabab? If you want to get coffee, you want to go to the bathroom, I already told the previous section, you can go without permission, okay? But please pay attention to the lectures, okay? Because when we write the exams, it will be based on the questions. Always get the latest. Do you access the OneDrive?
Yes.
Okay?
So, Doctor, I have a question.
Yes.
The update of the lectures will be after you provide it for us?
No, it depends. Always get the revision number. Every time I make an upload, it's a new revision.
Yes.
Okay? So if you take notes, just keep the notes, get all the revisions, and you can study all the revisions. When you stop taking notes, go to the next revision. Get it?
Yes.
Or you might merge them. It is the only way.
Yes, okay.
Watch YouTube if you want to take notes later. Okay? Make sure please try to subscribe, make comments if I have mistakes or anything. Okay? I want this to be a good learning experience for you. Any question? Let's begin. Are you familiar with Thomas Edison?
twice.
So Thomas Edison, this is his photo. In 1880s, he made lots of patents, okay? And these patents were sold to companies to electrify the lower Manhattan part of the New York City. Now, it had relatively small power plants scattered around the neighborhoods. As a matter of fact, one of the plants was the Pearl Street Station. This was 100 kilowatt, 110 volt. It had generators. This is how a DC generator looks like. If you want to have a DC grid, you have to have DC generator. If you want to have AC grid, you should have AC generator. Now, there are ways to move between DC and AC using power electronics or power converters. But what happened here is there were problems with the DC system. As a matter of fact, it was univoltage. The whole system had 110 volts. So if you look at this diagram, this is the positive, this is the negative. These are the generators, and the loads were connected. For example, 5 to 6. This is from positive to positive to the negative of this generator. This is positive and negative of this generator, etc. And it was based on loops. Okay, so this was the ground, this was the ground, and this is the positive, that's the negative. These are other additional shapes, how they look like. They took electricity branches and then they power the lamps across the grid. So there is no voltage transformation. ما في transformers. Transformers work only with AC. Get it? The distribution loops were short and full of cables. If you look at old pictures of New York City, you will find lots of cables hanging. Okay? And loads were lamps and possibly DC motors for traction. What are the traction? What does traction mean? الترام يعني traction يعني الحركة. فالترامات من أول وما زالت المترو تشتغل على الدي سي motor. Now Thomas Edison had lots of investments and he had companies, okay? And those companies hired engineers. One of the engineers who was hired was Nikola Tesla, okay? Nikola Tesla, he started to work with Thomas Edison, but he had a school of thought. He was doing research and doing patents, and he realized that, okay, it is better for us to generate AC because it's better for transmission lines. Are you all familiar with the equation P equal I square R? Remember this equation? P equal I square R?
Yeah.
So, if you have lower I, you will reduce P, where P here is the losses. So the idea of Tesla, he said, okay, I am going to increase the voltage, and when I increase the voltage, the current will go down because the power is voltage times current, correct? So if I increase the voltage, I reduce the current. And if I reduce the voltage similar to the DC, I will increase the current. So his idea was saying, okay, I'm going to have the voltage very high, but the current very small, so the I square losses are minimized. Get it? As a matter of fact, to get this high voltage, you really need to have large power plants. And one of them was Niagara Falls. Over long distances from New York City, it had 38 generators. I think 60% of them owned by the US, 40% by Canada, or 50-50, I'm not sure. But look at these numbers, 65 kVA, kilovolts times amp, versus a typical generator of only 100 kilowatt. So 100 kilowatt would power how many lamps? If every lamp is 100 lamp, how many lamps? 100 watt? 1,000 lamps. You get the sense of it? But if you have an AC 65 kVA, it's a different unit. I know it's a complex power, but we expect to power 65,000 lamps if we plus or minus, and you roughly get a sense of it. Also keep in mind this is a 23 kilovolts three-phase generator. The upper one was 110 volts DC. Transmission of electricity over long distances was the core idea behind it. Is I can transfer energy from point A to point B rather than having in every neighborhood a power plant. And this was clearly more economical. And the loads were incident lamps and induction motors. Class activity. In your phones, open this article. So this article talks about the war that happened between Thomas Edison and Tesla. And when I say war, I mean economic war, articles in newspapers, because it involved money. Money was the key factor why they had wars. So if you look at this, let's skim through this article together now and we'll discuss about it, and later homework, read the article, okay? I'm not gonna grade the homework, but you have to read it, please, okay? So, Tesla and Edison, one of the greatest inventors in history, they had a battle to dominate whether AC or DC should be implemented in developing new grids in the US. Well, it was a good time where money started to pour into after the Industrial Revolution. The battlefield between Tesla with the AC, supporting AC, or Edison supporting DC. And we call this the war of currents. And clearly, who won the war?
Tesla.
Well, not on a personal level, in a conceptual level. I'll tell you why. Sometimes if you... The concept won, but Tesla didn't win. I'll tell you why in this article. That's why I wanted you to read this article.
دكتور عندي سؤال.
تفضل.
الحين يعني السؤال يعتبر ممكن شوية بسيط، لكن كيف جاء على تسلا فكرة الاي سي؟
لأنه كان يشتغل على الحث المغناطيسي الاندكشن يعني الاندكشن وهي did الكالكوليشنز وهي realized إنه في الكالكوليشن you can play with the voltage levels easily. هناك ما كان في if you generate DC volts it has to be fixed voltage. بس he realized إن ال AC it is very easily you can change the voltage.
يعني هو كان شغال قبلها في الحث المغناطيسي وزي كذا.
أتوقع. أوكي؟ فهو كان يفكر كان مفكر وفي نفس الوقت يعني يبغى يطور السيستم. والاي سي كان معروف ذاك الوقت يعني هو اللي اخترع الاي سي كان موجود. And it's a sinusoidal wave عادي بس انه using it for transmitting power was his idea. Okay? But to answer your question, he used to work on machines, so he's familiar with the windings of the machine. And when he did the windings, anybody, even Lenz, had the physics, he was familiar with the windings. Okay? So DC current and AC current. So we all know that electric current is the flow of electrons. They apply from positive to negative. DC is a flat line. Sinusoidal is? AC is a sinusoidal line. When we see a sinusoidal line, what's the unit of omega t, ya shabab? It's radian, because omega is radian per second, t is second. So sinusoidal means like that. So the main advantage of DC currents is safety. The problem with AC is to get enough power transmitted, you have to have big voltage. And if you have big voltage, what will happen? Electrification. Low current, but if you apply a voltage on a human body, small resistance, you will still get the short circuit current.
Yes.
Get it? The problem is the high voltage. But for the 110 volt, it's a lower voltage. Okay, so the human body is a small resistor. small resistor على small voltage ولا small resistor على big voltage. So DC is safer, and the DC by nature is a smaller voltage. To generate 1000 volt DC, you really need very giant machine. But to generate 1000 AC, it is simpler. عشان مبدأ الحث المغناطيسي. Okay? Now, what is happening is direct current is safer, but AC is more efficient for transmission. Now, I'm not going to talk about the technical part. I'm going to talk about what happened here is Tesla, as a matter of fact, he worked with Edison in his company. Okay? He worked in a subsidiary of what would be biggest rival. Okay? But there was a problem with Edison. Not a problem. Edison was a powerful man. Why he was powerful? Because he had so many patents that he sold them and he already became rich. So now Edison was an employee, Tesla was an employee, Edison was the CEO, the owner. So can you tell your boss you're wrong? In this class I told you yes. I'm not your boss, but you can tell me I'm wrong. But usually, if in corporate environment, if the company is based on idea and you go tell them to change it, you will face some reluctance. Because even Edison, he knows AC is better, but he already had investments on that patent. So for him, changing his opinion, meaning throwing his money, his patent that was worth maybe $100,000 which post-inflation will be what? Maybe 2 million nowadays, will probably become less valuable and companies will start contract. So the issue was the money and of course the ego. And then the war of currents happened. And what happened here is that even though Tesla proved that DC is more expensive and efficient, Edison is smart, he said, but AC is not safe. And he provided reports and made the protest that AC was killing people. And he was right. Back then, the AC was not safe enough. So, Tesla's idea meant that electricity generated in the power plants could increase to high voltage transmitted over long distances with harder losses. But the problem here was bigger than what we expected. They said that the safety was the main issue. So in this part of the article, they talk about Thomas Edison. He aligned with J.P. Morgan. J.P. Morgan is a financial company. زي بلاك روك زي هنا في السعودية عندنا أمثلة عليها البلاد المالية الراجحي المالي شركة مالية investment. But they had investments to electrify the entire country with DC. So this was the beginning of General Electric Company. So Edison knew that it's less efficient, but he wanted the money and his ego to continue. Now Tesla had his own company now, winning more and more contracts. His advantages were clear, but he encountered serious obstacle that there were several fatal accidents. Tesla. فاللي حصل إنه due to high voltage of AC, Edison's side used death as an excuse to discredit Tesla and his AC company using newspaper. بس إنه حصلت مظاهرات، سووا مظاهرات against with Edison supporters applying mild current to animals. كانوا يقتلون الحيوانات بالAC عشان يقولوا شوفوا هذا قاعد يذبح الناس. Then they applied high voltage and then the animal died. So it spread the panic attack and the war continued. Now, unfortunately, Tesla's cause was not helped by the fact during these years, Edison اخترع الكراسي الكهربائية وhe used the AC to kill people في عقوبة الإعدام, the propaganda war. He lost. But they kind of reached a deal, they reached agreements. Tesla did not enjoy the fruits of his victory. So his idea won because he was required to sell his patents to the companies. يعني هي الكمبانيز فيها JP Morgan, فيها Edison, فيها etc. But in the end, Edison company already renamed General Electric, implicitly admitted defeat by applying. They took الباتنت حقت الكمباني هذا اللي ويستنج هاوس وحطوها في الجنرال الكتريك وصارت AC. they اشتروها بفلوسهم. But there were two different school of thoughts. Ultimately, Tesla he became, actually he died penniless. He died poor because he decided to focus later in science and technology, and he invented induction motors after that. And that's why Elon Musk named his company Tesla, to honor the induction motors, because Elon Musk was aware about the history. Induction motors now came into the picture with the electric vehicles, and we expect them to be more and more and more. And as a matter of fact, KFUPM has courses, if you go, that talks about machines 360, and there is, I think, one course in the senior level. So Edison won money-wise, Tesla won conceptual-wise. Okay? Read the article. I tried to give you an idea for those who are not going to read it. I know some of you will not, but please read the article. Yes, please.
عندي سؤال الحين، دام انه الاسي للدرجه هذه خطير، ليش في البيوت كلها نص الاسي؟
Because it became safer. الحين عندنا بريكر، عندنا طبلون، عندنا fuses.
اذا في احد طفل مسك ودخل سلكان حديد.
And that's why there are people every year they die. Kids die from.
معناته مو سيء.
It's not safe, but do you want to have a power plant في سكن الطلاب, power plant 59? We would have the same issue as HVAC system. The problem with an HVAC system is that it is decentralized. So every room has to have an air conditioner. Building 59 has a giant HVAC system. That is the problem. Is you think about the risk of having a kid touching this and you put your security thing versus the risk of having generators all over the city. Those generators might blow up. Also economic-wise. So yeah, it might be safer, but now with the evolvement of technology, there is what we call high voltage DC current. We're not going to talk about it, but there are in parts of the world now they're moving to high voltage DC current. It has other advantages beyond this discourse, but for now, let's نسلم إن the AC is the only way to go, and not only that, the AC, it is even the three-phase system. For the previous slides, I made update in revision 2. This is the new figure of the kingdom. The figure we had before was the old one. I uploaded the electric energy production. I added the word electric, as well as I added a new figure of power generation in the kingdom. Remember the number 423 in 2023? Electricity produced in the kingdom. This is the renewable share. This is the other clean. And this is the gas. So the goal is to make the gas more and more. It's better than the oil because the gas is cleaner. ما في احتراقات. يعني لما تحرق الغاز مو زي لما تحرق الأويل. Okay, it is cleaner. Plus the kingdom produces lots of oil that can be exported rather than being burned to generate electricity. So the whole idea of energy transformation program in the kingdom is to reduce number of oil barrels consumed and use gas, use renewables. So the renewables is increasing. The gas power plants are the way to go. We don't have coal in the kingdom. Okay? Let's go back to module 1 slide. Okay, so we talked about history. And you have to read the article. So a three-phase system is superior economically and from operating point of view compared to a single phase. Again, there was another battle, single phase versus three phase. Three phase is the way to go. Mathematically proven, the way the electric machines are designed. So every electricity in the grid, is this, what's coming here? Is it single phase or three phase? Single phase. So when we say three phase is outside in the electric grid, we don't mean inside the building. So this room could have the phase B, this room could have the phase A, maybe my office has phase C, I don't know, depending on how they wire the distribution cables. Okay? Get it, ya shabab? And remember the key word: generation, transmission, distribution. Get it? G, T, D. G, T, D.
في سؤال
تفضل.
هل في ممكن يكون فرق بين فيز A فيز B فيز C؟
الفيز شيفت هو الفرق. We'll talk about phase shift in a second. But so the only difference is A comes before B, B comes before C if you plot them in real time.
الانرجي ما فرق.
No. There is no difference. You can transfer more power in a three-phase than a single phase. We'll talk about it next lecture. Maybe next lecture. Now, let's start with the single phase. So this is the voltage source, V angles U. Okay, how do you transfer? What is the relationship between L and X? X equals something times L. What is this sum? Not omega. Only omega. What is the unit of omega? Radians per second. What is omega? 2 pi f. زي الفيزياء يا شباب، نفس حكي الفيزياء، physics 102. You remember it?
Yes.
What is F in Saudi Arabia? 60. What's the unit? What is F in Bahrain? 50. So students in Bahrain, and if they take E360, as a matter of fact, there is a story. I taught last semester a graduate course, a couple of lectures, and I had a student coming from Bahrain, and he's a graduate level. He works with BIPCO. اسم الشركة BIPCO حبيته. And we had this discussion is that electricity in Bahrain is 50 hertz. So when he solved the problems, he had to readjust his brain to 60 hertz. So in this course, unless I tell you it is 50 hertz, the default is what? There might be problems in the exam, I tell you 50, who knows? Okay? What's the unit of 2 pi? Okay, what is hertz? 1 over second. What's the unit of 2 pi? Radian. So that's why we have radians over second. Get it? So you know how to convert L to X and X to L? So X has a unit of ohm. L has a unit of Henry. So what's the unit of L? Henry. What's the unit of X? Well, I think Jx has the unit of ohm.
Oh yes.
I think X has a unit of ohm too. But we usually associate it with the Jx to make Z equal R plus Jx. You remember this from 213, صح?
Yes.
Who taught you 213? Multiple instructors. Okay, I'll go and fight with them. They didn't teach you three phase? Who studied the three phase في 213? حذفوها بس في أحد أكيد يمكن أخذها قبل. Studied the three phase? Was it big or small? Or you forgot?
Small.
Small part, very small. I think it was a. We'll teach you three phase here. So we're taking into consideration that it's your first time getting introduced to. That's why we talk about single phase circuit. Oh, before we start. Who does not have a complex number calculator? If you don't have, buy, please. If you really need one, I will always try to bring during quizzes, etc. But I need to borrow one for now, because I forgot mine. Can I borrow yours, please? And we will do a quick exercise now. Okay? In your calculator, make sure at number 2 it has complex. I'm going to do a quick calculation here, okay? 110 angle 30. So type 110. You know how to type angle? Shift علامة الناقص أتوقع اللي فيها الانجل. And then your calculator is in radians. So I want you please to come and change it to degree. It's okay to appear in the camera if you don't want. Can you change it to degree? So lesson number 1. Do not confuse degree with radians. Let's keep it degrees. خلاص?
change it.
Yeah, change it.
I change it.
خلاص يعطيك العافية. You know how to change it? It's easy. So the calculator should be in degrees. So type it 110 angle 30. What is the answer? I'm not going to give me the answer with a numerical number. 95.16 plus J times. Why we call it J? Because we don't want to confuse with the current. 55. So a phasor is nothing but a complex number. أعداد مركبة. If you look at the time domain equation, square root of 2 times v sub p. What does p stand here for? غلط. غلط. How come peak? The whole square root 2 times vp is the peak. It is the RMS, but why the book called it P? P from the word phase. Okay? So you can call it PH. Sorry, معلش. Now you will not forget it. خلاص؟
ايش الفرق بينها وبين الفي بيك؟
ال V peak, usually they write PK, is square root of 2V phase. بس انت فاهم ان square root 2 of sometimes the RMS is the peak, so they drop the H, they drop the K. I don't like it. You can call it VR. It's okay.
If you can explain this point, please.
Okay, square root of 2 times V of phase is the peak.
Yes.
Square root of 2 times 110.
Yes. Good.
هذه في بي لحالها اللي حطيناها هنا هذه في فيز. فكثير من الطلاب لما يقرا الكتاب يفكر ان الفي فيز يفكرها البيك ويفترض غلط. الكتاب مو غلطان، الكتاب يفترض ان هذه من بديهيات الامور انت فاهمها. فانا حبيت ابين النقطه هذه. اوكي؟ So square root of 2 times V phase times sine omega t. What are the identifiable information for the signal? Square root of 2 موحدة في كل مكان. V of phase changes على السيجنال. فهذه is an identifiable information. Sine is almost equivalent everywhere. Omega معروفة 2 pi 60. T changes with time. What is the phase shift of the first signal? 0. What is the phase shift of the second signal? Theta. It means the peak of I lags the peak of V by theta degrees. Because the load is inductive. If the load is capacitive, we would expect I's peak leading V's peak. I know it is a periodic signal, but if you look at القمم, قمة ال V تجي قبل ال I, معناتها ال I lags ال B. Yes, I is lagging. That's why if you have inductive we call it lagging. Lagging يعني متأخر. إذا كان capacitor I would lead V. Get it?
يعني حيكون في الكاباستر الفي هو اللاج.
Yes. We'll explain it later.
Victor,
Now, yes.
in this course we will be defaulted to sign, right?
You can use sign, yeah.
Because
No, in this course we will probably use the phasor notation. We will probably not use sinusoidal notations much. If you make it cosine, it has to be cosine minus 90. But again, if you shift this by 90, shift this by 90, they're still away by theta. So the phasor notation is the same. يا شباب الفيزر rotation you put الRMS or you put الphase shift. You don't put the peak في الRMS. Get it? Okay, is this slide clear? Now, let's move. The impedance, how do you calculate the magnitude of the impedance? It's the square root of 2 times of R squared plus X squared. من الأعداد المركبة, if you remember, A plus J times B, let's call this Z. Magnitude of Z is square root of 2, A squared plus B squared. You remember this? Math 01. Shargawi. Who took it with the Shargawi? I took it with the Shargawi. Solve the odd number problems. You solve the odd number problems? This course you solve all the problems. ما في odd, okay? Dr. Shargawi, I think he's the PYP math coordinator. Very smart, very much. Okay. Yes, we will allow the calculator in the exam, okay? Not like Math 01. Now, the phase shift is a feature that is identifiable by the circuit components. Get it? So to calculate theta, it is tan inverse of X over R. If you change X to a capacitive load, okay, you will add a minus sign. The minus sign will be incorporated inside the X of a capacitor. So that's why the theta will be minus theta for a capacitor plus theta for an inductor, because the X itself is going to be negative. We'll talk about it later. But if you remember, if you have a capacitor, it's 1 over J omega C. So what is X? Is minus 1 over omega C. عشان هذه الJ تطلع فوق. You want to put it in JX format. So X is minus 1 over omega C لأن هذه عبارة عن minus J over omega C. They are equivalent. الJ لما تطلع في البسط تصير negative. So what is X? خويتر?
minus 1 over omega C.
So if you have a capacitor, the minus sign will change the theta. That's why we have a difference between leading and lagging. Yes, we will have capacitors in this course. Now there is one more thing I want to remind you. Are you familiar with the Ohm's law? So Ohm's law, is this a phasor notation? Yeah, it's a phasor notation. Why? لأن هذه ال V هي عبارة عن phasor. لو لاحظت إنها مكتوبة كده شوية يعني ال V كده. In other textbooks, they use V tilde, the same notations. For typing, you can use in the exam problems V phasor to indicate this notation. But let's stick with the textbook. Okay? هذه يسمونها phasor notation. ال V هذه is a phasor notation. So V equal I times Z, Ohm's law. What is Z? R plus JX. So what is V phasor? Is V of phase angle theta 0. I is minus theta. So your minus theta, you go clockwise. And then IR, you multiply it by R. plus j times ix. If you have j in phasor, it's 90 degrees. You don't believe me, j is 90 degrees? In your calculator, type the word j or I. And then, how do you put this in phasor notation? Shift, number 2, and then you pick number 3, polar form, and it's 1 angle 90. That's why if you have a J, it's plus 90 degrees. You don't believe me? In the calculator, put J, convert it to the polar form or phasor form, and you will find it. YouTube, please do it, okay? Previous section. I didn't do it in class, J. Get it? Any question about this slide? Okay. Most of the loads pretty much inductive. So we expect usually the current to lag the voltage. Okay? Power. We have 5 minutes left. Are you all familiar with the equation P equal V times I? E to 1. Okay, I'm gonna put V, substitute this time domain waveform. This is what? Time domain waveform. Square root of 2 times square root of 2, it will be what? 2. V phase absolute value times I phase absolute value, they will become here. The reason we put absolute value just to make sure that this is a non-negative term. Tamam? Sine omega t times sine omega t minus theta, we have trigonometry. Math 002. I failed this course. No, I didn't fail this course. But I'm going to tell you one fact. In Math 002, I scored way below the average. So I really don't know what's the sine times sine trigonometry. I forgot. But if you do it, you will have those terms, 3 terms, P1, P2, P3. So P1 is V phase times I phase times cosine theta. Does this change with time? No, it doesn't have t. So it's a fixed number. It is a fixed number. Positive number. This term and this term, do they change with time? Yes. And as a matter of fact, they are twice of the frequency of the original V and I. So if you look at V and I, in one period of V, you will have 2 peaks of the power. So this P is P1 plus P2 plus P3 all together. So the frequency of the power signal is twice as the frequency of the voltage and the current. كيف عرفنا انها twice يا ذكرني باسمك؟ عمر ايش؟
عمر الكلدي.
عمر ايش؟
الكلدي.
الكلدي معليش انا سميتك غلط تحديد.
ممكن تعيد السؤال؟
Why the frequency here is twice?
Because we have positive
No.
alternating.
Because we have 2 before the omega. Twice the frequency. That's the reason.
Yes, yes. My answer was different.
What was your answer?
My answer was because of the rules of light.
Well, if you multiply it, yeah, you really multiply this times that. If you notice, for example, if one of them is 0, for example, here I is 0, the power will be 0. But the frequency is the same because this 2 omega from the trigonometry, Math 002. Who taught you Math 02?
بتروح الميموري.
Hmm?
بتروح الميموري.
دكتور ناجي موجود صح؟ He taught me Math 02. Okay?
كان في 2 وين راح؟ 2 في
Oh, this because there is a half in the trigonometry. There's half times. You don't believe me? Time is up. If you want to leave, you can leave. Rex. Hey.
بالضبط.
I didn't have internet. Yes.
مش باين.
Yeah, you can go. Oh, this is not the thing. جدا التحويلات اللي هي cosine of twice and sine x times sine A times sine B is sine A plus B and there is a half multiplied with it. That's why the 2 left. أي سؤال يا شباب؟ Yes. اللي ما حضروا يا شباب اللي ما حضروا في أحد ما حضرته؟ اسمك؟ معاذ؟ في أحد ما حضرته؟ طيب بليز next time don't be late يا شباب عشان ما تتأخر. علي؟ حاجي من بعد؟ طيب بس عشان اتاكد عبد الرحمن عزي موجود؟ احمد البلوي موجود؟
لا غايب.
انس الزهراني؟ Stop the recording.